Hello! Today we'll talk about a common misconception related to the merchant silicon chipsets, the programming speed. How fast can we program the route in NCS 5500? How does it compare to custom silicon? Common questions we will try to answer today. If you read the XR Docs publications and watched the videos, you certainly know that the NCS 5500 is based on a forwarding ASIC coming from the DNX family. For this demo, we will use a Jericho Plus chipset with an external TCAM. And since we are using iOS XR 632, it will be very easy. All routes, both IPv4 and IPv6, will be programmed in the external TCAM. We can store 4 million entries and even more, so we have plenty of space. The device under test is a chassis, 8 slots, and we are using a 36 ports 100 GB scale line card. We generate 1.2 million IPv4 routes from another router through a BGP station. So the idea here is to set up something realistic even if we are performing the test in the lab. So the prefixes are coming from a real router and not from a traffic generator. Quick look before starting the test. We see just 4 routes in BGP and 59 entries in the external TCAM. We are using telemetry to stream the ASIC and the BGP protocol statistics, and the frequency or the cadence that we will use for the streaming is 1 second. Now we unshut the session from the neighbor and take a look at the DUT. The prefixes are being learned from this BGP peer, and they are also programmed in the 4 NPUs of the line card. You can see the route on this graph, the dashboard we use here in Grafana. Now that everything is programmed in hardware, we can have a closer look at the graph. We identified 3 key moments here. Number 1, the moment we receive the BGP routes and start programming the ASIC. The second moment is when we receive the last BGP route, that's 9 seconds later. And the third and final moment we will look at is when we program the last route in the ASIC, and that's 41 seconds since the first route has been received. Based on these numbers, with a simple math, we can derive the programming speed. The BGP routes are learned in the route processor at 133,000 prefixes per second, and they are programmed in the hardware at more than 29,000 prefixes per second. To give a point of comparison, that's faster than ASR 9K with Tomahawk line cards. Also, we can perform the opposite test. We shut down the BGP session from the neighbor and check how fast the routes will be flushed. So we withdrew 240,000 entries per second from the route processor memory, and we flushed more than 34,000 prefixes per second from the ASIC table. Multiple internal improvements have been added to optimize the programming speed in these ASICs. And you can see that indeed the results are not different from what you could expect from a custom silicon device. More technical details will come with the blog post linked to these videos. As usual, don't hesitate to post comments and questions. Also, if you want to see specific topics covered, please let us know. Thanks a lot for watching. See you soon.